Hello students, you are welcome to Starry Gold Academy. This is Computer Studies. My name is Mr. Emmanuel Ayobami Ojo. I am your tutor for the subject. Now, the first thing we shall engage ourselves on is Introduction to Computing Devices. Here we shall be talking about the computer evolution, the pre-computing age during the 19th century. We shall learn about the features, their features, components, and some of their uses in early computing devices. Okay, introduction to computing devices. The history and evolution of today's computing system resulted from continued search for a tool that would enable man save precious time by meeting his computational and data processing needs. Below is a brief history of how the modern-day computers came to be. The first one is the abacus. The abacus was the first calculating device. It was developed by a famous Chinese mathematician called Jamb of the Ming Dynasty, who lived between 1368 to 1644 in China as early as 500 BC. The abacus is made up of pebbles or beads attached on strings, which are mounted in a frame. The different rows of beads have different values ranging from units, tenths, hundreds, thousands, etc. The beads are slid along the strings when counting. Readings are shown on the right-hand side. The abacus is used for addition, subtraction, multiplication, and division. It can also be used to obtain square roots and cube roots. Okay, this is what we call abacus. This is another abacus. The two are abacuses. Now, the component of this abacus is the pebbles, strings, and frame. This is the frame. This is what we call pebbles or beads. Okay, and this is what we call strings, in which the pebbles is being slid on. Now, the features of abacus is that the beads are slid along the strings when counting. Okay, and reading are always shown in the right hand side. These are the features of an abacus. The uses of abacus they are used for addition, it is used for subtraction, it is used for multiplication, okay, it is used for division, For square root, it can calculate, we can use it to calculate the square root. And we can use it could be used to calculate cubic root. Okay. Don't forget that I talked about the features of the abacus. I said the beads are slid along the strings when counting. That's the first features. And the second one is that the reading are shown at the right hand side. That is this place. Now let's move to the second computing device. The second one is called Napier rod. In 1617, Scotsman named John Napier, who lived between 1550 to 1617, invented rods, which are also called bones, for easy calculation of multiplication and division. And division of large numbers, for easy calculations of multiplication and division of large numbers. Okay. This made it possible for multiplication to be reduced to addition and division to be reduced to subtraction. A more advanced use of these rods can even abstract square roots of numbers. Okay, it consists of a set of 11 rods with four sides, each used as multiplication tools. These rods were made with bones. That's why we at times call it Napier bones. We don't want to call it Napier rod. Okay, this is the Napier bones we are talking about. This is how it looks like. Okay, now one of the components of this Napier rod we are talking about is that it's made up of bones. It's made up of what? Of bones called rods. Features. It is made up of bones called rods. Bones called rods. Okay. Then the uses, I said earlier that it could be used for calculation of multiplication of large numbers. The next computing device is called slide rule. Slide rule. This was invented by an Englishman who lived between 1574 and 1660, whose name was William Outred. Based on the emerging work on logarithms by John Napier. Okay, the slide rule uses two logarithmic scales to allow rapid multiplication and division of numbers. More advanced slide rules allow other calculations such as square roots, exponential equations, okay, logarithms, and trigonometric functions. This is how it looks like. Slide rule. Okay, the component here, from what I've said here, what I can call as the component here is that it's made up of that it has two logarithmic scales. That slide rule has two logarithmic scales. And one of the uses, or some of the uses, is that it can be used for the calculation of multiplication of numbers, division of numbers, square roots, exponential equations, and it could be used for the calculation of trigonometric functions. Even it could be used for logarithms, calculation of logarithms. All right. Now, next one, which I consider is called Pascaline. Some call it Pascaline. Pascaline was the first mechanical calculating machine, which was invented by a 19-year-old French mathematician named Blaise Pascal, who lived between 1623 and 1662. So he built this Pascaline we are talking about in the year of 1642. The Pascaline was able to add and subtract whole numbers. It consisted of a number of rotating wheels or gears, each having 10 teeth. The first gear counted in units. The second gear counted in tens. Okay? And the third gear counted in hundreds, fourth in thousands, and so on. It had the ability to carry digits to the next gear. So here now, in honor of his work, Professor Nicholas With named a computer programming language Pascal after him. This is how the Pascaline or Pascalines looks like. Okay, these are the gears we are talking about that has 10 teeth. Each of them has 10 teeth. Okay, these are the gears. Now, the components of Pascaline is that it has rotating gears or rotating wheels. Okay, the features is that one of the features is that it can carry digits to the next gear. The uses is that it was used for calculating whole numbers. That is it. The next one which I consider is called stepped reckoner. Step reckoner was a calculating machine that was designed in 1671 and built in 1673 by the German mathematician philosopher Gottfried Wilhelm von Leibniz, who lived between 1646 to 1716. The stepped reckoner expanded on the French mathematician philosopher Blaise Pascal's idea. Not only does it multiply by repeated addition and shifting, it also subtracts and divides. This is what is known as stepped reckoner. This is how it looks like. Stepped reckoner. Okay. Step reckoner, I said it earlier that it was used for multiplication, addition, subtraction. It could be used for division as well. Okay. So one of the features is that it multiplies by repeated addition. Okay. it multiplies by repeated addition. Like to say 2 times 10 now, it has to add 2 by 10 times to say 2 times 2 times 2 times 2 times 2 times 2. That is that. Now the next one we shall consider now is called Jaguar looms. Jaguar's loom. Jaguar's loom was created in 1801. A French textile manufacturer who lived between 1752 to 1834 automated the first mechanical means of weaving. Jacquard's loom was one of the first machines that were run by a program. Okay, it initiated the storage of information on punch cards. The punch cards were secured tightly alongside each other in a sequential manner. This is how Jaguar's loom looks like. Can you see that it is a machine? Now here, the features I would like us to get is that it used punch cards as storage. Okay, it used punch cards as storage. Okay, uses. This machine is used for weaving. It was used for weaving. Okay, now let's consider another device, computing device. It's called difference engine. Difference engine. This was invented by a mathematician, by somebody called Charles Babbage. Charles Babbage, who lived between 1791 to 1871. He designed the difference engine in the year 1822 and printed the first reliable mathematical tables that were in use for over 50 years. Okay, it could solve, this machine we are talking about could be used to solve polynomial equations using numerical methods called the method of difference. Charles Babbage difference engine is the first complete design for an automatic calculating engine. Okay, is the first complete design for an automatic calculating engine. This is how difference engine look like. Can you see how beautiful it was? Now, talking about that same difference engine, we are still on it. The uses, apart from that it could do some arithmetics, adding, multiplication, other things like that, it could be used to solve polynomial equations. Okay, and the features is that it was an automatic calculating engine. Okay, it was an automated automatic calculating engine. Okay, now let's consider another one called the analytical engine. The analytical engine was invented in the year 1834 by this same man called Charles Babbage. He was really a great man of inventions. Charles Babbage invented the analytical engine that was a general purpose programmable computing engine. Okay, it was programmable using punch cards. It contains computer components such as memory to use for storage, mill where we get arithmetic and logical units, input device, output devices. This logical structure of the analytical engine made Babbage known today as the father of computer. Okay, this is how the analytical engines look like. Okay, here the features of this analytical engine is that it was a general purpose programmable computing engine. It was general purpose one. Okay, and it used punch cards. And that feature is that it used what? Punch cards. It had memory. It used mail. It had input device, that is, it used input device, and it used output devices. These are the features. Okay, I said it was a general purpose programmable computing engine. Okay, 2, it used punch cards. 3, I said it had memory. 4, I said it used mail. 5, I said it used input device. And 6, I said it used output device. Okay, these are the features of analytical engine. The next one to consider is called the first programmer. The first programmer, Lady Augusta Ada Lovelace, who lived between 1815 and 1852. The Countess of Lovelace and the daughter of the illustrious poet Lord Byron became the first programmer when she wrote the instructions, that is programs, that would enable Charles Babbage analytical engine generate Bernoulli numbers. A computer programming language was named after her by the United States Department of Defense in the year 1979. Okay. Now, next one to consider is tabulating machine. The tabulating machine, an American statistician, Herman Hollerith, in 1887 developed an electromechanical machine called tabulating machine, which was capable of recording, computing, and tabulating what? Data. This machine was used to process data from the 1890 United States Census. It was the first machine to use electricity. It was the first machine to use electricity and the first to use punch cards to count, collate, and analyze data. This is how tabulating machine looked like. Okay. Now, from what I've said, one of the features of tabulating machines is that It was an electromechanical machine. Okay. 2. It used punch cards for counting, collating, and analyzing data. All right. Now, let's move to the next one to consider. It's called Baroque machine. Baroque machine. William Baruch built his first experimental model of an adding machine, which printed with printing adding machine with printing in the year 1884. The distinguishing features of this machine are the higher sloping keyboard. It has a keyboard. This is the keyboard. Okay, sloping keyboard. The beveled glass front, and the printing mechanism. The machine performs addition only. This is how the machine looks like. Okay. The use of this machine is that it was used for addition alone. It was only used for addition. And the features of this machine is that it has keyboard. It has keyboard which was used to inputting data. And it has a beveled glass front. Okay. And also it has a printing mechanism. That is it. So this is where we shall end the first class. I would like you to go through it and listen to this for better understanding. I wish you students best of luck. Thank you.